Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Total time for this exam is 1 hour and 30 minutes. You need to answer all questions on this paper and total mark for this paper is 80. On the last page of exam, you can also find some important data and also some important formulae. In the exam, if you need any formulae or if you have forgotten any formulae, you can go to the last page of exam paper and you can double check. Some important formulae are given to you. And also in the exam, you have to use value of G equal to 9.81 meters per second. You cannot use 10 meters per second. So these things are important. You need to understand some important formulae are given to you. And some important data is also given to you. Question 1 says, a quantity is either a scalar or a vector. Which row of the table is correct? In scalar column, if you look at this one, energy is a scalar, so this is a scalar. Momentum is a vector, so this is also true. This is vector, so it means this is correct, this is correct. So the answer for this question has to be A. If you look at next one, this is vector. This is in the wrong column. Acceleration is a vector. Time is scalar. Mass is scalar. Velocity is vector. Force is also vector. So the answer for this question is A. Second question says, which of the following is an SI unit for momentum? So momentum, simply we need to understand momentum P is equal to mv. SI unit of mass is kg and SI unit of velocity is meter per second. So the answer for this question is A. And momentum is a vector quantity. You also need to understand momentum is a vector quantity. Question 3 says, which of the following could be used to describe the elastic limit of a material? So first of all, let's try to understand what is meant by elastic limit. Elastic limit means this is the end of elastic deformation. So this is the limit. So simply we can say elastic limit simply tells us elastic deformation and plastic deformation. It simply tells us the value of the stress until that material behave elastically and after that material start behaving plastically. So this is the limit of elastic deformation. And at elastic limit, if we remove the stress, material will come back to original shape and size. So that limit we call is elastic limit. Now if you look at the given options, it is given to us the stress above which the material will not obey Hooke's law. This is not right actually. This is limit of proportionality. So this point is limit of proportionality. So this is limit of proportionality. So this is not possible answer. The stress above which the material will be deformed plastically when the stress is removed. Yes, because this is the elastic limit, end of elastic deformation. So this is our correct answer. And the stress at which the material undergoes a sudden increase in extension, that point is actually yield point. So we can say this is yield point. The stress at which the material breaks, that is the breaking stress. So we can say that is breaking or fracture stress. So these are the points you need to understand. Elastic deformation means that if you take your finger and you place on your cheeks, you see it deform. And then if you remove your finger, it come back. So this is elastic deformation. Question 4 says, a ball falls through air from rest. Which of the following shows the graph of displacement against time for the ball? So for the ball, we need to understand it started from rest. So the ball started from rest. So the initial velocity of the ball is equal to 0. When we drop the ball, this ball will accelerate. So we can simply say ball will accelerate. As ball will accelerate, it simply means that the speed of the ball, speed increases. Now if you look at the given options, we have displacement against time graph. So the gradient of displacement time graph, so we can say gradient of dt graph is representing velocity, or simply we can say is representing speed, or we can say is representing velocity. So it's better to say is representing velocity, because direction is also important. By convention we take up is positive, so by convention we take up is positive. As this ball is falling down, so it means that its velocity is negative, so the gradient has to be negative. And as the speed is increasing, so the gradient has to get steeper and steeper. So gradient has to be negative and gradient has to be increasing. Now if you look at given options, option A, this is telling us displacement remains constant. So it simply means that v is equal to 0. The gradient of this one is 0, so v is equal to 0. And gradient of this one is constant. So this is telling us v is constant. But in this case, velocity of the ball is increasing. So this is not possible answer. This is also not possible answer. Now if you look at option D, the gradient of this one is decreasing. So this is telling us speed is decreasing. Even if we consider effect of air, speed is increasing. Speed will reach a terminal velocity, but speed is not decreasing. Acceleration is decreasing, but the speed is not decreasing. So when this ball will reach terminal velocity, its acceleration will be equal to 0, but it will have certain maximum terminal velocity. So when the ball will drop, its speed will go on increasing, but its acceleration will go on decreasing. Very important. So you need to understand, speed of the ball will go on increasing and acceleration of the ball will keep on decreasing, if we consider the effect of air as well. So if you look at this one, this is telling us speed is decreasing. So because the gradient is decreasing, so speed is decreasing. So this is not possible answer. Now if you look at this one, this is telling us gradient is increasing. So it means speed is increasing. Gradient is negative. So it means velocity is negative, because down is taken as negative. By convention we take up is positive. So this is the best answer. So the answer for this question is C. So this is how you need to understand. At this level, simply you need to understand what gradient of the graph is telling you and what is the area under the graph is representing. So these 2 points you need to understand. If you can figure out these two, questions about graph are very easy. Let me explain you a little bit more about option D, because some of you still will not be clear about option D. Why option D is not possible answer. So the best way to look at option D is, if you look at the question, it is given to you ball started from rest and the gradient of dt graph is equal to velocity. So it simply means that the initial gradient has to be equal to 0. But if you look at the gradient of this at this point, this gradient is not equal to 0. So this is telling us it has certain velocity, and at the end, if you look at the gradient here, this gradient is equal to 0. This is telling you the final velocity is equal to 0. So this is like if you throw the ball from the ground, the ball go up, then ball finally reaches the highest point. So here speed of the ball will be equal to 0, and here it has certain velocity v. So the motion is like this. So that's the reason D is not answer. So the best way is look at the gradient. Gradient at time t is equal to 0 has to be equal to 0 because it started from rest, and the final velocity should have some value because in the air it will reach terminal velocity, and terminal velocity will not be 0. So the answer for this question is C. I hope it is very clear now. Question 5 says a helicopter moves vertically upwards with an increasing speed. Which of the following describes the increase in gravitational potential energy of the helicopter? So first of all, imagine that helicopter is moving upwards with constant speed. So we can simply imagine this is the helicopter. Let's say this is moving vertically upwards with constant speed. So we can say speed is constant. So it means that in this case helicopter is not gaining kinetic energy. So we can simply say in this case work done is equal to work done by helicopter. This work done will be equal to change in gravitational potential energy, or we can say gain in gravitational potential energy. But in this case helicopter is moving vertically upwards and also helicopter is gaining speed. So in this case we will say the total work done by helicopter is equal to change in kinetic energy, means the gain in kinetic energy plus gain in GPE, and gain in GPE is equal to work done against gravity, is the work done against gravity. So this is the point you need to understand, work done against gravity. If the speed is constant, so the work done by helicopter is equal to gain in GPE, gain in gravitational potential energy, or you can say increase in gravitational potential energy. If the speed is also increasing, so the work done is equal to change in kinetic energy plus work done against gravity, change in kinetic energy. So if you look at given options, first one is telling us the work done on the helicopter by the force of gravity. No, because work is done by helicopter, so this option is not true. And also in this case speed is increasing, so this is not true. Total work done by the helicopter as it moves upwards, that total work done is equal to the change in kinetic energy plus change in GPE. So this is not only the increase in GPE, so this option is also not correct. The work done by the helicopter against the force of gravity, yes, because that work done is gain in GPE, increase in GPE. So the answer for this question is C. The work done by the helicopter to increase speed, that is gain in kinetic energy. So they can ask you next time what is work done by the helicopter to increase speed, that is gain in kinetic energy. So the total work done by the helicopter, this is representing helicopter, so this is representing helicopter. So the work done by helicopter is used to increase its kinetic energy and also to do work against gravity, or simply we can say to increase GPE. So these are some beautiful points you need to understand. Work done by the helicopter to increase speed, this is increase in kinetic energy. I hope this one is clear to you. So the answer for this question is C. So we can also say this one gaining speed, so you can write on here, so gaining speed. Question 6 says an object moves with a velocity v. The kinetic energy of the object is doubled. Which of the following is an expression for the new velocity of the object? So simply we can start this question with kinetic energy. Kinetic energy is equal to 1/2 mv square. From here you can see that m by 2, this is constant. Mass of the object is not changing. So we can say kinetic energy over v square this is equal to 1/2 m, as this quantity is constant, so simply we can say the ratio between these two quantities remains constant. So we can write down here that kinetic energy over v square, this has to be equal to the new value of kinetic energy divided by new value of v. For this question, it is given to us new value of kinetic energy. New value is equal to 2 times ke divided by we have v new square. From here we can simply cancel this ke with this ke, and we can write down from here that v new square, this is equal to 2 times v square. Now if we take square root on both sides, we will get v new, this is equal to root of 2 times v. So this is new value of v, and this is a beautiful way. Why I explain you in this way? Because this method can be used to answer a lot of questions in physics. So that's the reason I use this one. Otherwise, simply I can say kinetic energy, this is equal to 1/2 mv square. If this kinetic energy is double, so this side also has to double. So that is possible if you have root of 2 v square. So from here I can say new value of v, so we can say v new, this is root of 2 v, so we can simply write down like this. But this method is very useful. So the answer for this question has to be A. Question 7 says a power station provides an electrical output power of 2.1 gigawatts. The power station transfers thermal energy to the surroundings at a rate of 3.4 gigawatts. Which of the following gives the efficiency of the power station? So in this case we have power station, so this is simply, you can imagine, this one is the power station. So the useful work output, means the useful power output is given to us, that is equal to 2.1 gigawatts. So this is the useful P out, useful P out. And we also have dissipated power, or we can say the wasted power. So we have also wasted power converted into thermal energy and transferred to the surrounding. Power output, wasted power output, that is equal to 3.4 gigawatts. So what is the input to this one? Input you need to understand, input has to be the sum of useful plus wasted. So this is our input. We need to calculate efficiency in this case, so this is symbol for efficiency, so this has to be P out useful, so this has to be useful over total P in, P input, P in. So we have useful, that is 2.1 divided by total, that is 3.4 plus 2.1. so the answer for this question has to be A. Most of the time students, they simply remember P out, but you have to find out useful P out. So this is the useful P out. So this is useful P out. Question 8 says a student applied a tensile force to a metal wire of length x and diameter d. The length of the wire increased by delta x. The student applied the same force to a second wire made of the same material. The length of the second wire increased by 2 delta x. Which row of the table could show the length and diameter of the second wire? For this question, it is given to us same force is applied. So the force is the same for 2 wires and same material. It means Young's modulus is the same, but spring constant is not same. K is different, but Young's modulus is the same because Young's modulus does not depend on dimensions of specimen. So we can start with Young's modulus. So we have Young's modulus is equal to stress over strain. So simply we can write down here, this is equal to stress over strain, and stress is equal to force over cross-sectional area of the material divided by extension over original length. Now if we simplify this one, we will get here Fx divided by A times delta x. This is equal to Young's modulus. We can also write down the equation for cross-sectional area. We can say this will be equal to pi by 4 d square times delta x. So here we have delta x. We can further simplify. We can write down y over f multiplied by pi by 4. This will be equal to x divided by d square times delta x. But if you look at the right side, left side, in this side, these quantities are constant. So simply we can say this will be equal to constant, So here we have x over we have d square, and here we have delta x. So it simply means that the ratio between these quantities for two wires is constant. So we can write on here, we have for one wire x square, and this is divided by d square, and here we have delta x. For the second wire, we need to find out value of x nu, and we need to find out value of d nu, and we have value of extension, that is 2 times delta x. Now from here we can cancel out this delta x with this delta x, so we left with x over d square. So here we have, this is x nu, and here we have d nu square, and here we have 2. Now that's all. This is end of this question. Now simply what you need to do is you have to take these given values and you need to replace x nu and d nu with the given values. One set of values will satisfy this equation, and that is your answer. So let's try with the first one. So we have x nu, that is equal to 0.5. So I can simply write out, this is 0.5 x divided by, we have 0.5 d square, and this is multiply by 2. Now from here you can see that 0.5 here we have, and here we have 2 0.5. So 1 0.5 will be cancelled. So what is left behind? We have x, and here we have 0.5 d square, and here we have 2. So if I rewrite this one, so it means this is x over, we have 1 by 2 d square, and here you have 2. So now you can see here, this is cancelled with this. So what is on the right side? Also x by d square. So it means this set of values, it satisfies this equation. So x nu is 0.5 x, and d nu is 0.5 d. So our answer for this question is A. A beautiful way. Very nice question, lovely question. So look at this question again. If you have any question, any doubts, please leave your questions in comments. And if this video is helpful, this video is helping you to improve your understanding of physics, and also if this video is giving you better understanding of these questions, please like and subscribe, because your encouragement is very important. With your encouragement, I will spare more time. I will make more useful and helpful videos for you. So please like and subscribe. You can also join Patreon if you need more help. Question 9 says, a box of weight W is suspended in equilibrium from a support by 2 ropes. The tensions in the 2 ropes are T1 and T2. Which of the following is a vector expression relating the forces acting on the box? In this question, it is given to you that the box is in equilibrium. So now simply you need to understand what is meaning of equilibrium. Meaning of equilibrium simply means that the vector sum of the forces has to be equal to 0. Vector sum. So simply we can say, if object is in equilibrium, vector sum of the forces acting on the object has to be equal to 0. Acting on the object has to be equal to 0. So simply we have three vectors here, so it means vector 1 t1 plus vector 2, this is t2, plus third vector, the sum has to be equal to 0. Vector sum of the forces on the object has to be equal to 0 if the object is in equilibrium. So the answer for this question has to be D. If your concept is clear, physics is just about concepts. If your concepts are clear, it's a fun to play with problems and solve problems. So try to clear your concepts. So the answer for this one is D. Question 10 says a box is pulled along the ground by a rope inclined at an angle of 40 degrees to the horizontal as shown in the figure. The tension in the rope is 30 newtons. The box is pulled 5 meters along the ground. Which of the following is the work done on the box? Work done on the box. We can also draw box here. So at this point we can draw, this one is the box. Box here. And box has been moved by 5 meters, so we can draw one line here, and the distance between these two lines is 5 meters. So this distance is 5 meters. So we can also label this one, this distance is 5 meters. Now we need to understand what is work done. Work done is force times displacement in direction of force. Displacement in direction of force. In direction of force. Or we can say work done is equal to component of force. So we can say component of force in direction of displacement. In direction of displacement, in direction of displacement, time we can say displacement, time displacement. So in this case force has two components. One is the horizontal component, and this component is in direction of displacement, so we have to take this component. But this force also has a vertical component. So which component is in direction of displacement? This component, and this component is 30 cosine of 40 degrees. So simply we can write on here 30 cosine of 40 degrees multiplied by the displacement. Displacement is 5 meters. So if we solve this one, our final answer will be about 115 joules. So the answer for this question is B. So this is the answer. That's all for section 1. I have explained you all the questions about section 1. I tried my best to teach you and explain you this question in a simple way, so you can improve your conceptual understanding and also you can have better understanding of these questions. That's all for today's video, and I'll be uploading remaining questions from section 2 as soon as possible. Take care of yourself. See you in next video, and also very happy New Year.